Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, solve the system of equations. So we are given three equations here with three variables. Let's take a look at some tips to help us solve. So tip number one, it's best to write the equations in standard form, meaning ax plus by plus cz equals d, to ensure all like terms line up vertically. Step number two, take two of the equations and cancel out a variable using elimination. Then take a combination of two other equations and use the elimination to cancel the same variable. So this might be the most important step right here. Step three, now there should be two equations with the same two variables. Just use elimination again to solve for the two variables. And then four, lastly, substitute the two known variables into any of the original equations to solve for the third variable. Now, here are two kind of odd cases where both variables cancel out and the resulting equation is false. Then you're going to get like 0 equals 3 or 0 equals -5. Then the answer is going to be no solution. Now, if the variables cancel out and the equation is true, like 3 equals 3 or 0 equals 0, then the answer is infinitely many solutions. All right, if you want to write these down, go for it or pause the video. I'm going to erase this chart so we have room to do our work. All right, so the first thing I'm going to do is label our equations here. So I'm going to label the top one equation 1, and then the second one equation 2, and then the third equation 3. All right, so we need to cancel out a variable in two of the equations, and then that same variable, very important, the same variable in two other equations. So I'm going to cancel out the x's because x is nice here because the coefficients are 1 in 1 and 2 and in 1 and 3. So let's go ahead and bring down those combinations. So I've rewritten 1 and 2 here and 1 and 3 equations here. And remember, we need to cancel out the same variable in both equations. It's very, very important. So I'm going to cancel out x's here. So I'm going to multiply the bottom equation by -1. So we're going to multiply the bottom equation here by -1 and rewrite both equations. So the top equation just stays the same. And then we're going to distribute that -1 to all the terms. So basically all the terms just switch signs. So -5y, -4z, and then -14. All right, next we just add all the like terms there. So the first guy, the x's here, cancel, and that was kind of the whole point, so I'll put a slash through those. And we have -8y, 2z minus 4z is -2z, 6 minus 14 is -8. All right, so this is awesome. Now we have an equation with just two variables. Now let's go over here and do the same thing for equations 1 and 3. We're going to cancel out the x's again. And which equation should we multiply by? Well, we're going to multiply the top equation by -3 so that the x's can cancel. So we'll rewrite both our equations here. We're going to distribute that -3. So it'll be positive 9y and then -6z. And then -3 times 6 is -18. And then we just rewrite our equation 3 right below it. And then we'll combine like terms here. So notice the 3x's cancel, that's the whole point. Cancel all the x's and we get 8y minus 7z equals, and then -28. All right, so there are two equations, so this is great. Now we've broken down the system of three equations to now two equations with the same two variables. So I'm going to erase all this work here, and then I'm going to rewrite both these equations underneath each other. So those are erased. Here's our two equations that we just got. Now this one, we're going to use elimination to get rid of one of the variables. Now in this case, the y's just cancel out. We don't have to multiply the top or the bottom equation by anything. So this one's really nice. So the y's just happen to cancel out right away. So I'll put a slash to that. We add the z's. We get -9z, and then equals -28 minus 8, which is -36. Next, we want to solve for z. So we divide negative 9. The 9's cancel. We get z equals negative 36 over negative 9, which is positive 4. All right, so we have one of our three variables. We have the z value. Next, we want to plug that into one of these two equations here so we can solve for y. So I'm going to plug it into this equation here, the top equation, 8y minus 7z equals negative 28. So I'm going to circle that 4 and show you what we're doing here. We're going to replace that into our z equation right there. All right, so let's go ahead and do 8y minus 7 times, I'll plug in the z equals 4 in blue, so you can see that that's what we're plugging it in for z. We simplify 8y, 7 times 4 is negative 28. We're going to add 28 to both sides to move that over. 28's cancel. 8y equals 0. We divide both sides by 8, and then 0 over 8 is just 0. All right, so now we have our y value, and lastly, we just need to find our x value. So I'm going to plug in z equals 4, y equals 0 into the top equation, equation number 1 here. So this top equation right here. So let's go ahead and plug in. So x minus 3 times, and y, which is 0, so I'll put a 0 there, plus 2 times z, and then remember z was 4, so I'll plug that in here. So we're doing this last step just so we can solve for x. So 3 times 0 is 0, and then plus 2 times 4, which is 8. So we have x plus 8 equals 6, and lastly we subtract 8 to both sides, and we get 8's cancel, x equals 6 minus 8, which is negative 2. All right, so there it is. So we have our x value, we have our y value, and we have our z value. So this is the point, so I'm going to write it as a point, where all three of these lines intersect. So negative 2, and then y was 0, and then z was 4. All right, so there's our answer.
Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.